Okay, so for the first reaction, what we're going to do is we're going to react magnesium, and of course we're going to react it with the air. And so what gas are we after in the air? Well, we're going to react it hopefully with oxygen. So that means we're going to oxidize this magnesium strip right here. And so the first thing that we're going to need is we're going to have to start our Bunsen burner. So we're going to go ahead and add a little bit of fire. And so let's go ahead and get our match. And so as we have our Bunsen burner going, tidy. I'm gonna try to see if we can control the air a little bit more. Lower. We don't need that much fan. Okay. All right. So now that we get that going, what I'm gonna do is I'm gonna get the magnesium strip, and I'm gonna place it over the flame. And as I'm heating it up, you're gonna notice something. Make sure, if we were actually doing this in the lab, we would try to avoid direct eyesight to what's about to happen. All right. So I'm gonna heat it up, and as I heat it up, you can see very nicely, right? And so what you can see left over is hopefully that magnesium powder, right? And I'm gonna place it on top of our table. And as I place it on top of the table, hopefully I'm gonna show you what is left over. And as you can see, what is left over is a white powderish solid, as you can see. And so that is what is left over of the product when you react magnesium and oxygen. Okay. The next thing we're going to do is we're going to measure out 3 milliliters of water in our graduated cylinder. And the reason why we're going to measure out 3 milliliters of water is so that we can continue, and we're going to pour it into a test tube so that we can use this as a reference, and we don't have to use a graduated cylinder every time we measure out 3 milliliters of water for this experiment. And so I've just measured out the 3 milliliters of water. And so I'm gonna get you close enough so that you can see, hopefully. Oops. Hopefully you were able to see everything that I just did. So I measured out 3 milliliters of water. And I'm gonna zoom you in so that you can see that we're at the mark. And then now all we're gonna do is we're gonna add it to our test tube that I've labeled 3 milliliters of water. And so every time that we need to measure out 3 milliliters of water, we would have to measure approximately that size. Now, test tubes do vary in size, so you gotta make sure that you use the same test tube, because it's not, it's not gonna be relative, right? And so every time I need to measure out 3 milliliters of water, I'm gonna approximate my my volume to that test tube every time we have to measure out that liquid. Okay. Okay, the next reaction we're gonna do is gonna be a reaction between zinc metal. So we're gonna get a piece of zinc metal and we're gonna react it with copper sulfate. Now, how much copper sulfate? We're gonna use 3 milliliters. So we're gonna use our reference test tube so that we can measure that amount. So before we add the copper sulfate, what we're gonna do is we're gonna get a small little piece or a chunk. Oh, don't wanna come out. Yeah. So we got a piece of zinc, and it's gonna be mossy zinc, so hopefully you can see it. There we go, the zinc. We got our chunk of zinc. And so what we're gonna do is we're gonna place it into our test tube. And as we place it into a test tube, all we're gonna do now is we're gonna add 3 milliliters of the copper sulfate. And so as you can see, this copper sulfate solution, and we're gonna use our pipette. And we're gonna add it. Now how much we're gonna add is we're gonna add approximately, I'm gonna get it closer. Actually, let me get it out. Let me add to go a little bit slightly to the side. See if we're about that size. Need to be one more addition. I think we should be fine there. Yeah. All right. So now that we've added our solution, we're gonna close our copper and clean up our little spillage, small. And then now we're gonna let it sit for 30 minutes approximately. Let me go ahead and take that off too. 30 minutes per se, so hopefully you can see. And after 30 minutes, we're gonna come and check it to see exactly what happened. Let me get you closer so you can get your initial and so there, so you can get your initial observation. We have the solution with the zinc in there, right? And we're gonna have a test tube labeled. So we're gonna come and check it after 30 minutes. That's it. So after our 30 minutes, we're gonna return to our copper sulfate solution and our zinc reaction. So remember, we added the blue solution, and we saw some, we had some zinc in there with some copper sulfate solution. And so if you can see now, man, I wish you could see, let's see here. There you go. If you notice, what was once the zinc was silverish, now it's brownish. And so that is the observation after 30 minutes. You notice hopefully that some of that zinc is now being coated with copper. So that brownish color is going to be your copper that is plating onto that zinc metal that we had poured in there. Our next reaction, we're going to react copper with hydrochloric acid. So here we have our little copper strip. So as you can see, the copper wiring, okay, I'm going to kind of bend it so that it fits inside the test tube. And so I've labeled the test tube right here, as you can see, with copper. And so what I'm going to do now is I'm going to add the little copper wire, and I placed it in the test tube. And then we're going to add 3 milliliters of the 1 molar hydrochloric acid to this, and then we're going to see what happens. We're going to do the same thing with zinc. So here we got another chunk of zinc, and we're going to place it into our test tube. We're going to also add, 3 milliliters of the hydrochloric acid to it. And then here we have magnesium. And so I'm gonna go ahead, the same magnesium, same type of magnesium that we had for our burning that we did previously. We're gonna place it into our test tube. And we're gonna also add 3 milliliters of this 1 molar hydrochloric acid. Okay, so here what we're gonna do is we're gonna add our first addition. We're gonna make our first addition, I'm sorry. And remember that it's approximately that amount of water. And so let me go ahead and put these back here so that we'll bring them as we need. And so we're gonna make our addition. And so as we make our addition, remember we're gonna add approximately 3 milliliters. And then we're gonna go ahead and close it. Now this is 1 molar hydrochloric acid. We're gonna go ahead now and see if anything's happening. And no, nothing seems to be happening with the 1 molar hydrochloric acid to copper. Okay, so just go ahead and record that. We're gonna go set it over here in the back, and then we'll come and check it again, right? So now we're gonna add the same amount of hydrochloric acid next to the zinc. And so here we go. All right. Nothing. And let's go ahead and do the magnesium now. Same thing, 1 molar, approximately 3 milliliters. And all of a sudden, when you notice with this one, It is bubbling, it is fizzing. And you see, hopefully you can see some gas formation, some fumes, and it is getting warm. Okay. Continue seeing there. I'm gonna zoom it in a little bit, so hopefully you can get a better view of what's going on. And maybe you can hear the fizzing of the sound production. You do have a small little scent that is being evolved from this. Almost smells like one of those antacids when you mix it with water. But it is getting very, very warm and nice. Okay. And still some magnesium in there. All right, and there you go. That's the reaction. So a little bit of heat being given off to the surroundings. Okay, so an exothermic reaction. Some scent, and also some bubbles. So that means we are forming a gas. And that's about it. Okay, so the next thing that we're gonna do is we're gonna do part D. And so in part D, we needed 4 test tubes, and I've labeled these test tubes. So we're gonna pour in here calcium chloride. So we're gonna add 0.1 calcium chloride, approximately how much? 3 milliliters. So here we have our reference, filled with water. How much? 3 milliliters. And then here we have sodium phosphate. So we're also gonna have a 0.1 molar solution of sodium phosphate, and we're gonna add about 3 milliliters of sodium phosphate as well. Here we have iron chloride. So we're also gonna add approximately 3 milliliters of the 0.1 molar solution. And here we have potassium thiocyanate. And so we're gonna add also 0.1 molar solution of that amount, 3 milliliters of each. Okay, so let's go ahead and make our additions. And so I'm gonna put these aside until I need them. And then, so we're gonna start off first with the calcium chloride. And so we're gonna go ahead and make our additions. And I'm gonna kind of separate these so I don't mess up and add them, right? And we're gonna add, we said approximately 3 milliliters. We're gonna use a reference, that way you don't have to, this is no quantitative analysis, right? We're not looking for values, all we're looking is for quality or qualitative analysis. That means we're basing off our experiment just on observations, and we're gonna use our 5 senses for those observations. So here we have approximately 3 milliliters of your calcium chloride, and so we're gonna go ahead and close our solution. And so we're gonna set this aside. The next thing that we're gonna make, so I'm gonna put this back until I need it. We're gonna get closer our sodium phosphate now. And so now, as you can see here, we have sodium phosphate. You're gonna make the same amount of additions, 3 milliliters. All right, and I believe we're good to go. I'm gonna set it aside over here. The next one we have is iron chloride. So if you notice our iron chloride solution, a little orangish. Okay, so we make our additions. Okay, maybe one more. Okay, one more. All right, there's about 3 mLs separated. Next one, we get our potassium thiocyanide. Here we go. Add about the same amount. And make one more addition. And there we go. All right, now what we're gonna do is we're gonna mix the solutions, test tubes, and determine what happens. So we're gonna mix calcium chloride and our sodium phosphate solution. So here we have 2 test tubes, and we're gonna pour one into the other. Does it matter which one? No, not necessarily. Okay, so we're gonna go ahead and make our addition. And as you see, we had 2 clear solutions. When we mixed it, all of a sudden now we have a murky white solution. All right, and so pretty much what we've done here is created a precipitate. So when we added one to the other, we had 2 solutions that were soluble in water, and then when we mixed them, all of a sudden 2 ions mixed, and when they mixed, they became insoluble. Okay, so that means it's no longer soluble in water. So here, make your observation. I'm gonna get a close-up. And so let's go ahead and get our close-up. Oops. Come on now. Aw. So as you can see, our close-up, we have, hopefully you saw that we have a murky solution. The next thing that we're gonna do is you're gonna have the iron chloride and the potassium thiocyanate, and what we're going to do is we're going to do the same. Okay, we're now this time, like I said, we're going to mix our iron chloride and our potassium thiocyanate, and as we do our mixture, so here we have 2 soluble solutions. Now I'm going to mix, and all of a sudden now we have a real red substance, right? So we had an orange, and hopefully you can see the redness to it. We'll get a close-up. Let's go ahead and get a close-up. Hopefully you can see the redness of it. And so that is part D of our chemical reactions lab. Okay, let me just double check to see if it is recording. We just had a technical difficulty. So now that what we're gonna do is I'm gonna go ahead and we're gonna add about a pea size of this sodium carbonate. So here we have our white powder, and we're gonna add about a pea size of the sodium carbonate into our test tube. And here we have our test tube. We added a little bit more than our pea size, but let's have some fun. And now I'm gonna add approximately 3 milliliters of our hydrochloric acid. And so here we have 1 molar hydrochloric acid. We're gonna add about 3 milliliters of this. And so let's go ahead and get that done. And as you can see, as we added the acid, we immediately started getting some fizzing. And so we got some bubble formation. And so let's go ahead and zoom in a little bit. And I'm gonna continue to move. And there you go. So we got some bubbles from our mixture of hydrochloric acid and sodium carbonate. So once we decided what happened already, so we already know what's going to happen with the sodium carbonate and the hydrochloric acid. So what I'm going to do now is I'm going to add approximately the same amount into our test tube, and then next thing that I'm going to do is I'm going to add acid. And one thing we're going to do is we're going to do a match test to see what possibilities of that gas could be that was formed. And so here I'm gonna go ahead and add, and as we add our acid, I'm gonna quickly come over here, strike a match, and if you notice, the match went up. Yeah. And so one thing that happened is I placed it in there. If it would have been a flammable gas, then all of a sudden my hand would have probably been burned. But of course the gas that is formed is not flammable. And let's go ahead and test it again since we still have some gas. Maybe not, right? Oh no, we do. Let's go ahead. If you notice, again, did burn off. Our gas being formed is not flammable. And see if you can figure out what that gas is. For the next experiment is going to be hydrogen peroxide, your 3% solution. Usually you get this over the counter at your local drugstore. And then here we have potassium iodide, and it's also 0.1 molar on the potassium iodide. This is 3%, 0.1 molar, and we're going to add 3 milliliters of each approximately to their respective test tube. And then we're going to go ahead and mix them together and see what happens. Okay, so here we have our hydrogen peroxide. We're going to get it close to our standard, right, measurement. We're going to add approximately those 3 milliliters. And then here we have our potassium iodide. We're going to add approximately the same amount. Let me go ahead and get this one out of the way. I don't want to mix it too soon. All right. So let's go ahead and it's almost 4 dropperfuls. Maybe one more. Now we're about there. So we got about 3 milliliters of each, and so the next thing that we're going to do is we're going to mix both of these together. So I'm going to pour one into the other. And as I pour it in, you can see that it's going from 2 clear solutions into a yellow solution. And here, hopefully, let me zoom it in. It is getting yellower. Oops, sorry. Let's wait a little bit and see if it turns a different color. If not, that's it. And there you go. A reaction between hydrogen peroxide and potassium iodide.